Alright, so today I want to go over the properties of the nth root. We have number one, the square root of x times the square root of y is equal to the square root of x times y. We have an example right here. Example A, the square root of 5 times the square root of 16. So what is that equal to? Well, first let's multiply 5 times 16, which will give us 80. And don't forget the square root, so it's going to be the square root of 80. We get that by multiplying the square root of 5 times the square root of 16 is equal to the square root of 80. But we cannot leave the 80 like that. We have to simplify it. How do we do that? With a factor tree. 2 times 40 gives us 80, right? So we just keep going on, factoring out the little numbers from 80, and that's how we're going to simplify it by hand. So again, repeat the process with the 40. 2 times what gives us 40? 20, right? 2 times what gives us 20? 2 times 10, right? And then 2 times what gives us 10? 2 times 5. Can we simplify any further? No, we can't. So this is as far as we're going to simplify, and we look for the square roots. We look for basically the numbers that, let's say, will multiply by itself to become like a square root. So like 2 to the 2 power is equal to 4. So we have 2 2's here. That's a perfect square. We have another 2 2's right here. So we have 2 times 2, that's 4, right? So this is going to give us, I'm going to write right here, 4. 2 times 2 is 4, right? 4, because it's out of the square, because they pretty much form perfect squares. But there's a 5. We cannot really form a perfect square out of 5, so we're going to leave it as square root of 5. Like that. Factor tree, find the perfect squares, take them out. Whatever is left has the square root under, like, over them, right? So 4 times the square root of 5. That is how you simplify it. So that's going to be your answer. Like that. All right, move on to the next one. Letter B, the cube root of 25 times the cube root of 30. Again, same process. You multiply the inside of the cube root, 25 times 30, which is going to equal to, you can use your calculator if you can't do this mentally, but that is going to equal to 750, I believe. 750. Don't forget the cube root. Again, we cannot leave this like that, so we are going to simplify it. So we have the cube root of 750. Basically, what the cube root means is that a number raised to the third power. That's what this means. This is a number raised to the second power. So 2 raised to the second power is 4. And right here, 2 to the raised to the third power, let's say, I believe it's 8. So correct me if I'm wrong, but I believe it's 8. So we have, so whatever raised to the third power is going to give us 750. And we need to find the cube root of it. So we do this with the same, well, not really the same process because it's a long process. But we can rewrite this as 5, obviously the cube root, 5 to the raised to the third power times 6, right? And we can plug it into our calculators. 5 raised to the third power times 6. Oops, sorry about that. 5 raised to the third power times 6, right? 750. So we rewrite it as that. 5 raised to the third power. Obviously, this is these are odd, so we can basically cancel these out because 5 to the third power, we already have that. So this is left with 5 times the third power of 6 because 6 does not have a third power. So it's going to be 5 times the cube root of 6, like that. And this one, you can do what I did here. I'm going to show you a simple example later on because this one's too big to be doing it. So it's just a matter of trial and error in your calculator. But you can do this with this one. It's just a longer process because that's a big number. But I'm going to show you a shorter number, smaller number that we can try this process on later on. All right. So the second example here, the second property is the nth root of x divided by y is equal to the nth root of x divided by the nth root of y. So let me repeat that again. The nth root of x divided by y is equal to the nth root of x divided by the nth root of y. Here's an example. We have the cube root of 216 divided by 8. Let's rewrite it in this format, how we went over it. That's going to give us the cube root of 216 over the cube root of 8. Right? Cube root of 216 over the cube root of 8. So what raised to the third power is going to give us 16? I would show you, the calculator will give us the answer, but it's going to be 6. 6, because 6 raised to the cube power is 216. So 6 raised to the power of 3, 216. So we already have that. Again, we can do this, but for the sake of it, I'm skipping it just to show you the rest of the problem. We're going to go back into a simpler problem for this later on. So 6 raised to the third power is equal to 216. That is how I got 6, because the cube root of 216 is 6, right? And now the cube root of 8. What is the cube root of 8? The cube root of 8 is 2. Why? Because 2 raised to the third power equals 8. Same with here. The cube root of 216 is 6 because 6 raised to the third power is 216. So now we have 6 divided by 2. And what is that? That is going to give us 3. So that is how you do this example. Let's move on to another one. The mth root and the nth root of x. We can do this by multiplying these two together, m and n. We can multiply them together to get m times n and take the root of whatever this is of x. Let's look at an example. The square root of the square root of 16. So if you didn't already know this, the square root is basically equal to like number 2, right? So there's two invisible number 2's here because this is equal to this. So let's just write them in just to make things easier. 2, 2, right? 2 times 2, what is that? 4, right? 4, well, that's an ugly 4, but whatever. 4, the fourth root of 16, right? Because 2 times 2 equals 4. And according to this is how we do it. So what what raised to the fourth power is going to give us 16? Box fourth power is going to give us 16. That is going to be 2, equal to 2. Why? Because 2 times 2 times 2 times 2 is equal to 16. Let's confirm it with the calculator. 2 raised to the fourth power, is equal to 16. And that is our answer. So remember, a square root basically has an invisible number 2 at the top. So 2 times 2, remember you multiply, is equal to 4. 4, the fourth root of 16, basically what number raised to the fourth power is going to give you 16? We see that it's 2, because 2 times 2 times 2 times 2 equals 16, right? So the answer is going to be 2 for this example. Number 4, basically the nth root of x raised to the nth power, these are going to be the same integers, is equal to x, basically this, if n is odd. So if these two are odd, it's going to equal to x. So let's look at an example right here. Let's look at an example. Oops, there we go. All right, so we have the fifth root of -7 raised to the fifth power. These two are odd. So that means it's going to equal x. It's going to equal the number inside, and the number inside is -7. So this is going to equal to -7. Because these two are odd. The inside number, -7, according to this concept property, that's what it's going to equal to, right? Let's look at another example. The nth root of x to the nth power is equal to the absolute value of x if n is even. So we have obviously 4, the fourth root of -2 raised to the fourth power. We have two 4s right there. They're even, so it's going to equal to the absolute value of -2. Absolute value of -2, which is going to equal to 2. Right? Because it's even. And according to that, that is how we do it. If you don't know what an absolute value is, it's basically just a measure of distance. That's all it is. Absolute value can basically never be a negative, because distance is not negative. We cannot have -2 miles. We can only have 2 miles, right? So that's absolute value is a measure of distance. I'm not going to go too much into absolute value here, but basically the basic concept of that is that absolute value is a measure of distance. So now let's move on to another example. We have the square root of hold on a second. We have the square root of 360 divided by the square root of 10. So let's basically do this problem. Basically we can see that the square root of 10 doesn't really have perfect square, because the multiples of 10 is basically just 2 times 5, and those do not form a perfect square. So that's as far as we can simplify the square root of 10. But let's move on to the bigger number, the square root of 360, right? So what times what is going to give us 360? Let's start with 2. 2 times what is going to give us 360? 2 times 180 will give us 360. 2 times 180, right? Again, 2 times what is going to give us 180? 2 times 90, right? 2 times 90 is going to give us 180. And now, 2 times what is going to give us 90? 2 times 45 is going to give us 90. Now, what two numbers multiplied is going to give us 45? 3 times 15 is going to give us 45. Now, what two numbers will give us 15? 3 times 5 will give us 15. So again, we look for the perfect squares. 2 and 2 are perfect squares. 3 and 3 are perfect squares, right? But 2 does not have a perfect square, a partner to basically get with, doesn't have a partner. It's by itself. So we have the perfect square of 2, and we have the perfect square of 3. And what is 2 times 3? It's going to be 6. 6. And since this 2 is left without a partner, without a square, it gets to have the square root. So it's 2. Oh, shoot. Sorry about that. I missed the 5. I'm so sorry about that. That was my mistake. So these two do not have partners. They do not have, a 2 cannot go with a 5 and be partners, right? It can't. So we basically multiply these two. So 2 times 5 is 10. So I'm sorry about that. Ignore this. 6 times the square root of 10, right? Because these two are partners because they're the same. These two are partners. They're the same. They're perfect squares. So it's 2. 2 has a partner and 3 has a partner, right? 2 times 3 is 6. They do not get the square root because they are perfect squares. 2 does not have another 2 to go with, and 5 does not have another 5 to go with. So they're not perfect squares here. So we multiply these two together to get the square root of 10. The 10 does get a square root because it is not a perfect square. And then we put it over the square root of 10 because that is what we're doing with the problem. This is this simplified. So now we have 6 times the square root of 10 over the square root of 10. These two cancel out to just give us 6. Like that. So that is how we solve this problem, because this will equal to basically number 6. That is it for this problem. Now, I believe this is the last one. The cube root of 360. I'm gonna show you how to take the cube root of 360, basically following this model that we did right now. So the cube root of 360. Let's start with 2. 2 times what is going to give us 360? Basically the same thing we did here. 180. 2 times what? 180 is going to give us 360. 90. 2 times what? 45, I believe. Yep, 45. And 3 times what? 3 times 15, I believe. And then 3 times 5. So now we look for basically triplets. Right here we look for doubles, twins, or whatever, I don't even know. Right here we're looking for triplets because there's 3. There's a cube root. We need 3 of the same number in each group. And we see here that there's 3 number 2s, so they go in a group, right? They make a perfect cube. Is there 3 3s? No. Is there 3 5s? No. So they are left without a group. So again, we have 2. They do not get the cube root sign. Why? Because they're a perfect group of 3, right? Triplets, whatever. So now we have 2 number 3s and 1 5. They cannot go in a group in a group of 3 because they're not the same number. We only have 2 3s and 1 5. So what do? We multiply. 3 times 3 is 9, times 5 is 45. Again, they do get the cube root because they do not make a perfect cube. So that is how you simplify this problem. Just like that. Those are the properties of the nth root, basically n being any integer, any real number. So, and that is all I have for today.